Have you ever wondered how airplane speeds are measured? It's not as simple as just looking at a speedometer. In aviation, different types of speed measurements are used to ensure safe and efficient flight. Let's take a brief look at these measurements. Firstly, we have the indicated airspeed or IAS, which is the speed shown on the airplane speedometer. Then there's the calibrated airspeed, CAS for short, which is the IAS corrected for instrument errors. The equivalent airspeed or EAS considers the effect of air compressibility for planes that fly over 500 kilometers per hour. The true airspeed TAS is the EAS corrected for changes in air density. Lastly, we have the ground speed GS, which is the airplane's speed relative to the ground. In the coming scenes, we'll delve deeper into these speed measurements and understand their importance in aviation. Let's begin with IAS, or indicated airspeed. This is the speed indicated on the aircraft's speedometer. It is the most basic, raw airspeed reading, uncorrected for any instrument or environmental variables. Simple yet fundamental for basic flight operations. Next, there's CAS, or calibrated airspeed. This is the indicated airspeed corrected for instrument and position errors. Now, each aircraft has a specific table or graph in the flight manual to obtain the CAS. It's a bit more nuanced than IAS and gives a more accurate airspeed reading. Moving on, we have EAS, or equivalent airspeed. This is the calibrated airspeed converted for the compressibility effects of the air for aircraft flying at high speed, typically over 500 kilometers per hour. It's a bit more specialized, but incredibly important for those high-speed flights. Then we come to TAS, or true airspeed. This is the equivalent airspeed corrected for altitude and outside air temperature. It's the speed of the aircraft relative to the air mass in which it is flying. So when you hear pilots talking about their true speed, now you know what they're referring to. Lastly, there's GS, or ground speed. This is the speed of the aircraft relative to the ground. It's the true airspeed adjusted for wind speed and direction. When you're tracking a flight on your phone and it tells you the plane speed, that's usually the ground speed you're seeing. These speed measurements are crucial in the operation of an airplane. Understanding them is fundamental to maintaining control of the aircraft, executing maneuvers, and ensuring safe and efficient flight. They may seem complicated, but with a bit of practice, they become second nature to pilots and aviation enthusiasts alike. And remember, speed in aviation isn't just about going fast, it's about precision, control, and safety. Now onto some standard speed symbols like VNE, VNO, Virginia, VS1, and VS0. First, let's tackle VNE. VNE stands for never exceed speed, the maximum speed permitted for an aircraft. Going beyond this speed can cause structural damage or even failure, so it's a limit pilots dare not cross. Next, we have VNO, or normal operational speed. This is the maximum speed at which an aircraft is designed to cruise under normal conditions. It's the sweet spot pilots aim for when they want to travel at a high speed without pushing their plane too hard. Moving on to VA, or maneuvering speed. This is the highest speed at which you can use full control deflection, for example, a full hard-over rudder movement, without risking damage to the airplane structure. It's a critical speed to know when you're flying in turbulent conditions. Then there's VS1, the stalling speed or minimum steady flight speed, at which an airplane is controllable with its wings level and landing gear retracted. It's a crucial speed to be aware of, especially during takeoff and landing. VS0, on the other hand, is the stalling speed or minimum steady flight speed when the landing gear is extended and the flaps are in landing position. It's another vital speed to consider during landing scenarios. There are also some additional speed symbols worth mentioning. VFE, or maximum flap extended speed, is the highest speed permissible with the flaps extended. VLE is the maximum landing gear extended speed, which is the highest speed at which you can fly with the landing gear extended. VLO is the maximum landing gear operating speed, the maximum speed for extending or retracting the landing gear. Lastly, we have VLD, the lift-drag speed, which corresponds to the maximum glide ratio. It's the speed at which you can achieve the greatest distance for each unit of altitude lost, particularly important in engine-out scenarios. Understanding these speed symbols is key to ensuring safe and efficient flight operations. Airplanes can also be classified into different classes. Each class is distinguished by specific characteristics such as the number of engines, the type of propulsion, passenger capacity, and the maximum takeoff weight. Let's start with Class A. This class includes multi-engine turbo airplanes, either jet or propeller-driven, that can carry more than 10 passengers and have a weight exceeding 5,700 kilograms. This category is defined by the European Union Aviation Safety Agency, or EASA, under its CS25 regulations. On the other hand, Class B airplanes are smaller. They are equipped with propellers and designed to carry up to 9 passengers. Their maximum weight is less than 5,700 kilograms, in accordance with EASA's CS23 regulations. Understanding these classes is essential for appreciating the diversity of aircraft designs and their respective performance capabilities. These classes help us understand the capabilities and limitations of different types of airplanes. So we've covered quite a lot about airplane speeds and performance. We've learned about the different speed indicators used in aviation, such as indicated airspeed, calibrated airspeed, equivalent airspeed, true airspeed, and ground speed. Each of these measurements has a specific purpose and is used under different flight conditions. We also discussed the standard speed symbols like VNE for never exceed speed, VNO for normal operational speed, and VA for maneuvering speed, among others. Understanding these symbols helps pilots operate their aircraft safely and efficiently. We then moved on to the different airplane classes. We learned about Class A and Class B airplanes and their different capacities and performance characteristics. In conclusion, all these elements of speed and performance are crucial to ensure safe and efficient air travel. Next time you're on a flight, you'll have a better understanding of the speeds mentioned by the pilot and the performance of the airplane. Until then, keep flying high.